So we are starting to get, Tim is already here. I can't see his presentation up to now, but I think it's going to be just in a second. Our next presenter here is Tim Usner. Tim is working for FOGTEC, the provider of water systems from Cologne. And he's going to give us a talk about a recent renovation in the United States. I'm just preparing the presentation here. Oh, where is it? Okay, so.
Hi, good.
Tim, stage is yours.
Hi, I hope you can hear me.
Looks good.
Okay, perfect. So thanks, Götz, for the short introduction. My name's Tim. I'm the project manager for the Carey Tunnel here on FOGTEC side. And I'm going to present you today a case study of the refurbishment of the Carey Tunnel with a water system. So let me just give you a quick overview of our company, the company FOGTEC. We are about, we are a mid-sized company, about 150 employees, and we were established in 1997. Our headquarters is based here in wonderful Cologne, and we've got some few other offices and a partner network of about 45 partners worldwide. So our tunnel department is well known for its full-scale fire tests, where we did over 200. We did the first CO2-rated control system for a water mist system, and other high-class references such as Eurotunnel or the Dartford Tunnel, where we installed the CO2 system. Besides that, we are doing many turnkey installations and also detection and control systems beside that. Today in my presentation, it will be about the Carey Tunnel. That's a tunnel located in New York City in Manhattan, and it's a fairly old tunnel. It was opened in 1950, so 70 years old. And you can see here it connects the Manhattan Island with Brooklyn, and it's about 2.8 kilometers long, has a design fire load of 30 megawatts, and it's formally known as the Brooklyn Battery Tunnel. So some of you may know it as Brooklyn Battery Tunnel, but it was renamed after governor. Just as a small side fact or fun fact, the photo you see here on the right, it's from a CO test, which they did back in the days. It's a ventilation test. So all of these cars have the engines on, and they had CO measurements points. And if they would have reached critical levels, the cars needed, or the drivers need to get in the cars and drive out. So you wouldn't do it like this nowadays, but back in the days, that's how they have done it in the Carey Tunnel. We've got a full transversal ventilation system here and several exhaust and blower buildings. One, for example, here is on the Manhattan side, here on the Brooklyn side, and the biggest one is on Governor's Island, which you can also see on the picture here, and it's a fairly huge building. It's also a tolled tunnel, so that means for the city of New York, it's of high importance that we've got a high availability and that the tunnel is open, because if it's closed, that means no money for New York City. The reasons why they choose the water mist system as a refurbishment technology was that, or it first occurred after a major car fire several years ago, and then the authority having Juristication, they had some first apprehensions in regards of fire risks. And the main problem is that some of the major components of the fans in these blower buildings, which I showed you, they are not suitable for high temperatures. And the hot gases, which are passing here through these exhaust ducts, will then pass also the fans. And that's why they were looking for a technology or for a method how they could cool down the gases and the fire loads inside the tunnel. So that's why they choose a water mist system, because it's got quite a high cooling effect, and it's also space-saving in technology in regards to fixed firefighting systems, but I will come to that a little bit later. A request by the client was that all major components need to be placed inside this air duct. So all pipe work, section valves, nothing inside the tunnel. The only thing which shall be placed inside the tunnel are the nozzles. You can see here I marked it with red arrows. These are the small vent openings where the hot gases will go into the exhaust duct and then outside of the tunnel. We had to lead the nozzles through these exhaust vents into the tunnel. So yeah, the nozzles are the only visible thing inside the tunnel. As we have very less space inside the exhaust duct, water mist system comes in hand as it is a quite space-saving technology. You can use smaller pipework, and also the nozzles can fit through these openings. What was also of benefit is that, for example, compared to a sprinkler system, the water mist system uses less water. And as it is in a refurbishment, they didn't want to redo or redesign the drainage, because with a fixed firefighting system, we bring additional water into the tunnel. And as they didn't want to redo the drainage system, they were looking for a technology which uses less water. And due to the smaller pipework, it's also quite easy to retrofit it into a tunnel. Before the acceptance, we had to do a spray test. You can see here on the picture with the red arrow that we were pulling the nozzles inside the tunnel, and then we did set the emergency ventilation mode to on, which comes with a wind speed of about 3 meters per second. And we wanted to see how much water mist gets pushed into the exhaust air duct. As you can see here, there is a small spray pattern behind the exhaust vent, but nearly all of the water stayed inside the tunnel. So the authority accepted it, and we were able to go forward with the water mist system. As the temperature inside the exhaust air duct are a critical point, it was quite good that we collected a lot of data in the past. And one of these data was that we did measurements with thermocouples inside a test tunnel. So we did put thermocouples inside an air duct and did measurement points. And so, for example, this here is a 200 megawatt fire, Class A fire, and after 12 minutes, we activated the water mist system. And as you can see, the thermocouples didn't get any temperatures above 50 degrees, which is quite beneficial for this project. So some of the challenges which we had and still have, it's quite narrow inside this air duct, this exhaust air duct. So the left picture here, you can see a hatch, and all of the pipework needs to get into this exhaust duct through this hatch. So pipe after pipe, it's quite a hassle. And the installation is done during full operation, which is always a challenge. And it's also the first water mist system inside a tunnel in the USA. So at least for them, it's a fairly unknown technology, which means for us that we have to do a lot of, say, guidance and consultancy, because it's an unknown technology for them. And yeah, as everyone, due to COVID-19, we did fully remote project management, but until now it worked out quite well. And just last week, we did our first purely online factory acceptance test. So typically we would invite the customers to come over to witness the FAT, but as it was not possible for them to come over, we did it purely online, and it worked also quite well. As you can see here, we need loops in order for the temperature and the movement of the pipework, but we have to, of course, prevent already existing equipment inside the air duct. So we had to adapt the pipework accordingly, and just to not damage other existing equipment inside this air duct. The last picture here is one of the nozzles, which is going into the tunnel with a flexible hose. This is, it's easy for installation, and it needs less prefabrication when you use these flexible hoses. As you can imagine, space is very limited in New York City. This building you see here, that's the blower building on the Manhattan side, and this is also where the pump room needs to be installed. You may recognize this building. It's actually also shown in a movie called Men in Black, and in Men in Black it functions as the headquarter of the MIB, so maybe you recognize it from there. And the 3D drawing here shows where we need to install the pump room. It's the only space available here where we can install the pump room. So yeah, space is crucial. And also many regulations have to be taken into account when you want installation inside New York City. Just as an example, we had to audio test our pumps on different frequencies, how much decibel they are going up to. And this had to send this files and data over to New York that they can approve that we didn't have reach critical levels. This was quite new for us as well. But positive side is that we only need one pump station, and this comes in hand here with this less space available. One of the other tender requirements was that the fixed firefighting system shall be full-scale fire tested. And as we did so many fire tests in the past, we were able to have this data adapted into the Carey Tunnel, and then we got it third-party check by a consultants company in Berlin. They are called IFAB. They also wrote this test report. So they had a look at the data which we collected during our fire tests, how we adapted it to the Carey Tunnel, and wrote this report, which was later then also accepted by the authority in New York City that we are good to go. What was also a requirement was that we shall use as less core drillings as possible. So as you can see here, these are the air ducts which I showed on previous pictures. And we had to put the nozzles through here. And luckily for us, the nozzle layout which we had in the fire tests, they were nearly the same distances which we have here in the exhaust ducts. So not many core drillings were needed in order to keep the layout from our fire tests. This was quite important for the end client to prevent core drillings where possible. A few words about the implementation of our system. Right now we have ongoing installations inside the air duct. Parallelly, we are doing the prefabrication just in order to save time. The civil works for the pump room, they are going to start in January. And you may remember the picture which I've shown of the blower building. This is taken out of the movie Men in Black. This is Will Smith running to the blower building. So just as a small fun fact. And full project completion will be done in 21 next year. We are using a stainless steel main pipe, which is connected by welding and connected as a ring main pipe then, and all of the other pipework is done by press fitting. So what we also have is a brake tank inside the pump room. You see it here on the picture marked as yellow. And so we don't have a full water storage. And this brake tank, it's connected to the water supply of New York City. So if the system is running during a fire event, the water from the city of New York will again fill the brake tank. So we have a constant water flow inside the tunnel itself. We did put the components for the control of the valves all inside the fire protection box. You can see it here also marked as yellow, and also the valves inside, because this fire protection box, it has a valve protection enclosure. It has a fire rating of about 1,100 degrees after 30 minutes per UL 7009. And we did also put 2 valves per box just in order to be space saving, as space inside this air duct, as I mentioned, is a real hassle and issue. So as a summary for this case study, what can you take with you? So we provided a full-scale fire-tested system. Due to the small pipework, it's quite easy to retrofit it into an old tunnel. And up until now, we are doing the complete project management remotely. So may it be over Zoom meetings or through HoloLens. So we've never been to New York on the project management team side. So that's quite challenging for us as well. And no major delivery problems until now, despite COVID-19, which is good as well. Next week is going out the last shipment. And as we had already collected data from fire tests, no additional fire tests were needed, because these full-scale fire tests, they are quite costly and time-consuming. So one of these full-scale fire tests needs to have a preparation time of about a year. So it was good for the end client that we already had this data and that they could use it. And also that we could use the layout, the nozzle layout from the fire test, and that it did fit these exhaust distances quite well. No major core drillings not much core drillings were needed. And minor adaptations we did with this flexible hose, which I showed on the picture, and it's quite good to use these flexible hoses on site. Yep, that's it from my side. Thank you for your attention. If you have any questions, please see here my contact details, write me a mail, give me a call. And thank you and have a pleasant weekend.
So everyone, thank you, Tim, for your very interesting presentation. One thing that interests me, I see there are some.
There's one question from Max. So it's a basic function of the system in this case to cool the fumes, not to put out the fire. Tim, could you reply on this, please?
Yeah, so at first it's a suppression system, so it shall not put out the fire, but that's what all fixed firefighting systems inside tunnels are for. The distinction of the fire will always be done by the fire brigade. So it's there to suppress the fire, to keep it small, and if the fire is kept small, also the hot fuses will reduce. And it's not the only reason, but it was the, let's say, first reason why they wanted to have the system. It's also cooling the concrete and the environment itself, and that's why they choose it.
Yeah, thank you.
Thank you, Tim. So this puts us directly, since there are no additional questions, this puts us directly to the wrap-up that we have here right now. So Tim, I will just skip you out a little bit here.
All right, no worries.
Don't take it personal, please.
No.
So right now you have Roland and me here as the wrap up for our little conference here today. I think we heard some interesting stuff about new renovation techniques, and I think it was a good way to present things in Corona times. Actually, I have to say I've never been to part of such a conference up to now. I've given lots of lectures and lots of speaks and talks at different conferences around the world, but this is for me a total new thing. Sitting here in my office and talking to whoever is listening, which I cannot see actually, is a really strange thing. Roland, I don't know how you feel like at this moment.
Yes, it was a very new experience to me also, because we were to organize it and also to switch between the sessions and put the presentations on the screen and the presenters on the screen. So we had to click a little bit here in between, and then even to move from one session to the other. So that took some seconds of time, and as it was the first time, so I think it was quite a good experience which we had now. But maybe one word again to the technical part. So I was really impressed by all the presentation which were given. So they had some impact on the structural parts, like your presentation, Götz. We had also a very good practical example from Schiphol Airport. So that was also very impressive. And in the last presentation, we had some good example what can be done to protect quite an old tunnel against the fire incidents which may occur. And last but not least, the presentation of Peter, that was very interesting from my point of view, because we must not only think about the finished tunnel, but we also have to think about the operation and even during the refurbishment that there also persons are working inside the tunnel. So and they are, they have to cope with the dust and all the not very human friendly environment, which also could be seen at the last presentation of Tim. Because you have to work in this exhaust air duct, which is not a very big height and not very friendly to work in.
Yeah, and I think.
And you have to work with imperial units from the USA.
Okay.
Yeah, and I think this is something that we really have to think about going into the future. We will not in countries like Germany, France, Europe as a whole, but also the United States, we tend not to build new tunnels more and more. We tend to renovate and retrofit the existing ones. And to do that, we need clever and sophisticated concepts, not only for retrofitting them, for bringing them up to technical levels that we have right now with newly built tunnels, but also how we manage the risks during the retrofitting. Unfortunately, we did not have a presentation here about the risks during retrofitting measures, but I know from discussions with operators in Germany that this is one of the biggest problems at the moment, that we, especially when we are dealing with road tunnels, because the risk profile that has been developed, let's say a couple of years ago when the tunnel was built, did not take into account the situation where you maybe, for example, you have a bidirectional traffic tunnel, and then you have, during the refurbishment works, you have to guide the traffic through one tube, and these are things that we really have to put more focus on in the future, especially when it comes to research. And there are still lots of open questions in my mind.
Yeah, and I absolutely can agree, Götz, because Robert Missen said it already before. The tunnels on the 10T network, and not only these tunnels, they are the bottlenecks of our networks. And if we close down a tunnel for renovation, we just have to keep the traffic up. And that requires, for example, like you said, bidirectional traffic, and that, of course, faces other risks than it originally was planned for. So I think quantitative risk management and such tools, which are already in use now, but they have to be adjusted to the new risks for these special purposes which we will face in future.
Yeah.
And maybe one word again, as I said it at the very beginning. So have a look at the amount of tunnels. Just only taking Germany as an example, we have about 1,600 kilometers of tunnels, and we are building about 200 kilometers of new tunnels just at the moment. And but you have to keep up these 1,600 kilometers, and even with every new built tunnel, the challenge will be greater. So yeah, I think there might be very big tasks before us, so which we have to solve.
Yeah, I think this might be a good final remark here. I hope that everybody enjoyed the session here. I hope that everybody grabs himself a beer or a coffee. I think it's Friday. Friday is mostly gone, so maybe you are already in position to get a glass of wine. That's going on with Karen, I think, is going to present and going to say some words again together with Eric Lecar. So there's still something going on here, and I just saw that I received some messages. I'm going to take care of that. And with these final remarks from me, I want to thank you for your participation here. Thanks again to all the presenters. Thanks, Roland, for being a host together with me here. And to everybody else, stay safe, stay healthy, have a nice Christmas, and I hope for everybody, as good as this was, I hope that we are going to see in person and in reality in the near future. Bye bye.
Same to me. Bye bye.